Welcome to part 3 of the video series on Buck Converter Module BUC01. Today we will try to achieve constant output voltage using PID control. Firstly, we will consider LED lamp load to maintain constant output voltage. In the next setup, we will manually increase a rheostat load and see the results of PID control. We here have a buck converter module which is connected to Arduino board. The input to the buck converter is given from a regulated DC power supply. At the output side we have two LED lamps of 12 volts and 9 watts each. These lamps will be connected to the output terminal one at a time. Follow this connection diagram for Arduino and buck converter. Now let us quickly go through the Arduino program. We start with including the PID and PWM header files. Here few variables are declared which are used in this program. We set the switching frequency to 100 kHz. Then we define the variables used for PID control. Next, we set the values for tuning parameters of PID control. And we call this PID function with desired set of variables. Here, digital pin 9 is set as output pin. Here we assign digital pin 9 for PWM generation at 100 kHz. This line in the program allows the user to define the desired value of output voltage. And then we turn on the PID control. Inside the loop function, we first read the upper and lower MOSFET temperatures. To calculate and print the actual MOSFET temperatures, these two functions are called. This functions continuously monitors the rise in MOSFET temperature. Next, we read the input and output voltage values. These lines calculates the actual voltage values in terms of volts. The input and output voltage values are printed on the serial monitor. Here, we assign the output voltage value as the input to the PID control. The PID controller computes the corresponding output as per the difference between the input and set point values. The output from the PID control is the duty cycle value. This duty cycle value adjusts the output voltage of the buck converter. We then map the duty cycle value within the range of 0 to 230. Then finally we pass the duty cycle value to generate the desired PWM signal at digital pin 9. Now we upload the program to Arduino board. We start the experiment by switching on the power supply. The input voltage is set at 20 volts. This time you can open the serial monitor from the Arduino tools menu. Here you can observe the upper MOSFET temperature T1. The lower MOSFET temperature T2. Input voltage values V1. And finally output voltage values V2. We firstly start by connecting one of the LED lamps to the output terminal. You can observe that the output voltage is stable and constant at 12 volts. However, the input current has increased to 0.5 amperes. We again increase the load by adding another LED lamp at the output terminal. Input current has now increased to 0.8 amperes. But the output voltage is perfectly stable at 12 volts. To prove the robustness of the systems, we even tried changing the input supply voltage. Here you can notice a perfectly constant output voltage of 12 volts. The user can set the desired output voltage to any value. In the new experimental setup, the input voltage is set to 24 volts. A 50 ohm rheostat is used as load. So we start by increasing the rheostat load. You can see that the input current increases gradually. But the output voltage is constant at 12 volts. Now we have reached to the point where the input current is around 3 amperes. We now bring back the potentiometer to its initial position. Observe constant output voltage. This confirms successful implementation of PID control for buck converter. Thank you for watching. Don't forget to place your order. Link in description.